So let's mix things up a bit. Let's change some of the values here and see how inappropriate addressing causes devices to not be able to communicate. So in this example here, same idea, but we changed addresses or we've changed subnet masks. So analyzing the first two, they're still /30s. So based on /30s, we know we're counting by 4 in the 4th octet. So our first subnet would be 10.1.1.0. Let's clean that up. 10.1.1.0/30. And then we have .4/30. And we have .8/30, and so on and so forth. So if I analyze now the addressing, .1 is in the first subnet. .5 is in the second subnet. So that's not going to work. It's not going to work at all. Likewise, with our second example, with our Ethernet network between our two routers here, this case as well. .1 would be in the first subnet because we're dealing with a /30, and .5 would be in the second subnet because we are dealing with a /30. So definitely here, inappropriate addressing. So we're not going to have communication between these routers. We're not going to be able to ping between these routers. Looking at our next example here, we're a /29. So let's see how this significantly changes what's going on here. So with a /29, what do we have? We have 8 in the first, 8 in the second, 8 in the third octet. So that's 24, 25, 26, 27, 28, 29 network bits. 30, 31, 32. So what is the value of that bit position? That value is 8. It's 8 in decimal. So we're counting by 8 in the 4th octet. So my first subnet, we have 192.168.1.0/29. And then we have .8/29. And then we have .16/29. And then we have .24/29. All right, so we're just counting by 8 in the 4th octet. So now we can start comparing here. So we have .1. .1 is in the first subnet. .10 is in, second subnet. .3, that's in the first subnet. .11, oh wow, that's in the second subnet. .12, second subnet as well. .13, second subnet as well. So right now the router and the switch are addressed for the first subnet, and all the PCs are addressed for the second subnet. So is communication going to occur? Well, all the PCs are going to be able to talk to each other. They're not going to have any problems talking to each other inside their local area network. Because if one of the PCs want to talk to another PC, they recognize that the IP address is in the same subnet, and they go ahead and just send frames locally. But what if they need to talk to somebody outside their subnet? They actually don't have a default gateway they can talk to because their default gateway belongs to a different subnet. So they will not be able to talk to their default gateway because, according to them, their default gateway is in another subnet. Therefore, they will not be able to communicate with their default gateway. They will not be able to send traffic outside of their local area network. So inappropriate addressing causes communication not to occur properly in your organization. So addressing is of the utmost importance, and you need to be able to recognize when devices are not addressed properly. Like in this scenario, we had to figure it out by determining our block size, figuring out the subnet IDs, and then comparing the IP addresses to each of the subnets and figuring out where each of those addresses lived, and ultimately determining that some of them were in subnet 1, some of them were in subnet 2, when they should have all been in the exact same subnet.